Okay, welcome dear participants. Yes, let me admit first again. Disable waiting room. Yes, then everyone can join, really. Okay, welcome dear participants. We will begin the seminar in about 1 or 2 minutes. In the meantime, we are allowing a few more minutes for everyone to join. A quick reminder for you, please make sure your Zoom display name matches your full name as used during the registration, first name as first name plus last name. By joining this session, you are considered to have accepted a data privacy consent as part of your registration process. During the session, you may ask your questions by unmuting yourself and speaking directly, or by using the Q&A or chat sessions. Thank you for your participation, and we will get started shortly. Okay, again, please make your names as first name plus last name as you registered to the event for our statistics and dissemination activities. So, let us start then. Yeah. Good afternoon, everyone, and welcome. It's a pleasure to open the third session of 5 Beats of Intelligence, AI Meets Diverse Domains seminar series, a joint initiative under the EuroCC-4C project. This collaborative effort brings together national competence centers from Turkey, Serbia, Montenegro, North Macedonia, and Bosnia and Herzegovina. With each session, we explore the diverse intersections of artificial intelligence with different domains of science, technology, and society. I would like to thank to all the project partners and country representatives once again for making this joint activity possible. Today we are continuing the series with the title Talks AI meets computational social science, and our speaker is Dr. Marija Mitrovic Dankulov, Head of Innovation Center at the Institute of Physics Belgrade, and AI lead at Reputeo. She is also our colleague from NCC Serbia. In this session, no, okay? You want to correct something, Marija?
No, I will correct later, but I can share.
Okay. And in this session, she will walk us through the applications of large language models and AI-based tools in simulating and analyzing online communities, particularly platforms such as X and Reddit, with a focus on sentiment analysis, toxicity, detection, and topic modeling. Marija, thank you very much for joining us today, and the floor is yours. First of all, your correction. Thank you.
No, I will do it during the presentation, so no worry. But
Okay.
can you allow me to share? Because now it doesn't allow me again.
For sure, yes.
Okay, no, it does not. Okay.
Maybe now.
Let's see. Okay, cool. Is it in presentation mode? Yeah?
Yes, for sure.
Perfect, thank you. Okay, so the correction. Thank you very much for Suzanne for organizing this, the whole series. It's quite interesting thing. And thank you for offering the opportunity to talk a little bit about how me and my colleagues use AI in a field that we are working for Now for me it's almost 20 years, but for younger members of my team, my colleagues, they're slightly less involved in this for a shorter time, but very much involved in that sense. So I'm a head of innovation center, as Suzanne said, at the Institute of Physics Belgrade, but I'm also a research professor at Scientific Computing Laboratory. And actually what I'm going to tell you about is from this part of my life, everyday life. So it's about scientific research and how we use AIs in our scientific research. Besides this, I'm also a lecturer at master courses in computing in social sciences and advanced data analytics at University of Belgrade. As Suzanne said, I'm also AI lead in a company, Reputeo. That's a startup from Belgrade that does, basically, we offer a platform for data collection and data curation. And of course, I'm an industry champion in National Competence Center of Serbia within the EuroCC for SCE project. So I'm a physicist by education and by choice. So how physicists ended up with social systems? Actually, it's not something very unusual, but we specifically, in some sense, use physical approaches, physical models, physical paradigms, and frameworks to study collective social behavior. And this is not something that is new, as I will tell you in a few slides, but what is the collective behavior? So basically, everything that we see in our everyday lives, from Mexican wave that is shown here, to schools of fishes, and through the epidemics that we actually observed for the past 4 years, so to say, these are all collective behavior in social systems. What is the characteristic of collective behavior is that it doesn't exist without the interactions between people, and it's actually emerging behavior of social systems, or to say social systems are part of the class of complex systems. So any complex systems exhibits this emergent behavior or this collective behavior. And we actually because physicists observe this collective behavior in systems that are typically physical systems, like magnetism and superconducting or superfluidity. We observe this behavior there, and actually many of the models that were developed for studying these kind of behaviors can be actually applied to social systems. But I'm not going to talk actually about this, although I will mention a few things. But actually I'm going to tell you how we use AI in studying these systems. So computational social science is a relatively new emerging field in science. It's a highly interdisciplinary field. And what you can see here is there is a national flagship conference organized every year. It's called International Conference on Computational Social Science. Actually, the first conference was in 2015 in Finland. And in one of these conferences, colleagues asked everyone who are attending the conference to tell them from which scientific discipline they're coming, and whether they consider computational social science as their field of research. So as you can see, there are a lot of people from computer science, there are people from physics, there are people from complex systems and network science. This is actually mostly part of physics. Mostly physicists are working in these fields, but we also have colleagues from economics, social network analysis, communication sciences, of course, from sociology. And to be honest, in 2015, when I attended the first conference, I was surprised that more than 90% of people there were colleagues from physics and from computer science. But luckily, after 10 years, we actually see more and more colleagues coming from social sciences, from humanities, from economics, and other fields that actually naturally belong to this computational social science field. Of course, data science is there. Computational social science wouldn't exist without data science, and vice versa. So in that sense, it's quite vibrant field. it kind of gets together people from very, very broad disciplines. And I would say we are just at the beginning of development of this field. What is an artificial intelligence? When I was preparing this talk, I was talking to my younger colleagues, and they said, we don't see that as an artificial intelligence. And actually, maybe a few years ago, I would agree with them, but then I started teaching this course at one of the master courses at university, and I realized that many of the things that we are actually using in data science, sometimes in physics, but especially in computational social science, already belongs to artificial intelligence. We usually see this deep learning as something that isn't artificial intelligence, but actually it's much broader. So basically most of the machine learning, not most, machine learning, of course, belongs to this, but also rule-based systems, different kind of game theory systems. Game theory is quite popular in computational social science because it helps us to understand the cooperation and competition in social systems. Of course, how we represent knowledge and reasoning. Search algorithms, graphs, or complex networks are kind of, you cannot take them out from computational social science. It's actually where we started to collaborate, and different kind of other things that we see in this. They don't mention agent-based modeling here, but actually intelligent agents that are typical for artificial intelligence. Some type of agent-based modeling is also very much used in computational social science. So the connection is natural. And I would say that more and more as we develop, these two fields will become more and more connected. So I usually, when I have to explain why physicist is studying social systems, I say that physics and social sciences, it's a relationship that lasts more than 2 centuries. Actually, some of the most prominent frameworks and disciplines within the physics, like statistical physics, actually was motivated from social sciences, where people realized that certain statistical properties with people, such as, I don't know, average height or average weight or other things that you can average on the certain population, are kind of stable over regions or over time. And that's how Maxwell, not Maxwell, but yeah, Maxwell actually realized that to study gases, which have very large number of interacting molecules, he doesn't have to actually describe behavior of each molecule, but he can actually use the distributions. And then from there, the statistical physics was basically born. While we kind of drifted apart, in 20th century, more and more colleagues from social sciences, from geography and so on, started noticing that one of the most prominent models in statistical physics, Ising model, is something that can be very nicely used to model certain processes in social systems, such as voting behavior or polarity, opinion polarization, and this kind of stuff. So kind of it became more and more popular to use Ising models to explain certain social phenomena. And in 70s, Santa Fe Institute started with having these collaborative meetings where economists, social scientists, computer scientists, physicists got together, and they tried to use different kind of very simple toy models to explain social phenomena. One of them is Schelling model of segregation, where they actually show that while you can have a very tolerable people, so they can tolerate people of different race and still have polarization or segmentation in a system. Of course, the computational social science actually started in 21st century when we changed how we use the web. From consumers, we allowed people to become creators of content, to collaborate, to interact with each other. And due to this, Web 2.0 became a very beautiful and very rich data source for scientists. And of course, physicists like these kind of things. And they jumped into this, collecting different kind of data from online social communities, different kind of behaviors. Of course, computational resources became more accessible to all of us. And as a consequence of this, we had more and more physicists and computer scientists interested in social sciences. And today we have more and more social sciences who are more interested in, who are becoming more interested in actually using computational approaches in their research. Oh. So, as a scientist, as a physicist working in computational social science field for the last 20 years, I actually have three approaches working on this. One is an empirical analysis. So basically, I'm collecting different kind of data depending on the phenomena I would like to look at, from whether they're online communities or maybe even gathering the data from different kind of sources, such as, for instance, telecom companies and these kind of stuff. But of course, and we apply different kind of methodologies, both from computer science and from physics and from complex network theory to actually study these empirical data and to quantify different kind of collective behavior. There is a book called Everything is Obvious Once You Know the Answer. And this book tells you that, yes, it's nice to have this empirical data, but this is only one.
İyiyim canım.
Sorry?
Ee,
But this book actually tells us that empirical analysis is just one point, one specific point in time for a specific system, or it's just one path that you can actually look, and this system, depending on initial conditions, could have different kind of paths. And for these reasons, we use actually agent-based modeling. And these agent-based are data-driven agents. So this means we use a lot of information from the empirical systems to actually kind of calibrate our models, and we use them to model human behavior and their online social interactions. Experiments are not that rare, but are still kind of rare because they're not simple. They're usually very complex to make because unlike physics experiments where you can really make controlled situations with people, you can with design of your experiment, you can introduce different kind of biases. So yes, we plan to do this in the next year, but basically what we are mostly doing are empirical analysis and agent-based modeling. My first encounter with computational social science happened in 2009. It was a project called Cyber Emotions, Collective Emotions in Cyberspace. And it was EU-funded project. We had 8 organizations from Poland, Germany, Austria, United Kingdom, and Slovenia, where I was actually settled as a student there. And we had several data sets produced during this project from BBC Blog, from Twitter, today X, from Dig, from MySpace, from different kind of IRC channels. And what our goal was is to actually study how collective emotions and their emerge and what is their role in creating, forming, and breaking up e-communities. During this time, we produced also some agent-based models, but we also had a sanctity strength, emotional classifier that was produced for emotion extraction of text from the data. And sanctity strength was actually used during the London Olympics in 2012. The tweets were estimated, the emotional content of tweets was estimated using sanctity strength, and this was kind of broadcasted through London Eye. So this is kind of curious thing, but it was one of the interesting outcomes of our project. And what I will tell you more is what type of data we actually used, and how we extracted the emotions from these data. So one of the beautiful things of the data from online communities is that they have a very high temporal resolution. This is sometimes important if you want to study dynamics of the system. It is also important if you want to study the evolution of social network in these systems. For all of these data that I mentioned in the previous slide, we had either posts or comments, or posts and comments. We had information about their posting time. We, of course, had information who was creating them and who was replying or commenting them. And we had text. This was an important thing. For users, the good thing is that we had a unique ID. So this means that we could follow the behavior of one person through time. And we actually were able to look at the structural networks and how these networks evolved through times. And this allowed us to also look at details about the activity of these people. Our focus was on emotions, and we actually extracted emotional context from text. This was actually a classifier problem, and we could either have zero or positive, neutral, or negative emotions. So basically 3 classes of emotions, or we could have a score of emotions from -1 to -5, which is a kind of negative emotion, and from 1 to 5, which was kind of positive emotion. And actually strength was actually using this approach. But what I will tell you is actually the case where we had actually only neutral, positive, and negative. So what we have done at that time, so this was one of the first classifiers, emotional classifiers, that I knew of at the time. So we had 2 data sets. One was BBC blogs, not very large actually data sets, because we kind of focused on a smaller number of posts and smaller number of user communities. But we were interested in actually studying in details how different kinds of states emerge in this system. And also Dig. Dig was something very similar to Reddit, today's Reddit. The only difference was it wasn't about stories, but actually people share different kind of links to outside stories, so blog posts, news articles, and so on, or they shared links towards some videos on YouTube. People could vote up and vote down these stories, and they could comment and make and develop a discussion about specific post on the specific post about the topic that was set up with this post. And what we have done is to analyze emotional content for posts and comments in the BBC blogs. And of course, for Dig, we didn't have for posts because these were mostly links. But we actually studied or analyzed the emotional content of comments. And for this, we used a very simple language model classifier. Every comment or every post was considered as a document, and we had 2 classifiers. One classifier was used to determine whether the post or comment is objective or subjective, and the other one was used to determine whether, if the post was subjective, whether it's positive or negative. The classifiers were trained on blog's 06 dataset. This is a dataset that has almost 30,000, more than 30,000 documents, and it was collected through several years of a conference where people actually were labeling the documents as objective or subjective, and if they were subjective, then they were deciding whether the post was positive or negative. And at the time when this classifier was trained, its accuracy was 70%. And actually, as far as I know, for most of the classifiers today, the accuracy is higher, but it's usually around 85%. So we cannot go beyond this because there are certain situations where even people who are labeling the documents cannot agree on the objectivity or polarity of specific document. And we actually use this algorithm to extract emotions both for BBC blog and DIX. And how we use this data then? Well, we actually map the data onto a complex network. This is a type of bipartite network. Bipartite means that we have two partitions in the network. One is partitions of posts, these are squares, and partitions of users, these are blue circles. And if the post is black, then it's negative. If it's yellow, if it's white, then it's neutral. And if it's red, then it's positive. And we looked at how different dynamics so you can analyze this network, you can find communities. These are a group of posts and users who are more connected with each other than with the rest of the network. These groups, you can actually look at how these groups develop through time. You can look at the size of these communities, how it's changing with time. You can look at number of comments that you observe in these communities, but you can also look at polarity, number of emotional posts. This is Q. And you can also look at how the charge, so the number of positive minus number of negative posts is behaving in these systems. And what is an interesting thing is that usually, typically, you have several of these communities. They are very active during one period of time, but then they die out. So in this period of time, this is already existing system. Some other communities was very active, and it kind of died out when this other community became more active. So basically, you kind of have this switching of emotional behavior. What is more interesting is actually looking at the DICs. So for DICs, and you can also do this for BBC blogs, you can look at the time series of activities. So time series of emotional comments, this is a green line, and time series of negative comments. DIG is quite negative community or social group. Actually, more than 50% of comments on DIG were negative. So this kind of showed that negative emotions are what is driving the community. Again, one of these communities and its behavior is shown here. So again, we map this to bipartite networks, found communities, and look at how dynamics of these communities is through time. But what you can do with this time series is actually you can do something that we use in statistical physics. We look at different kind of properties of this time series. So one of them is power spectrum. And what we found out is that we have 1/f noise, which is typically seen in the systems that have long-term correlations and are actually also seen in the systems that are in state of self-organized criticality. Self-organized criticality means that the system is constantly having these avalanches, so it's constantly in the critical state. And there is no outside parameter like temperature in the case of magnetism, where by increasing the temperature, you go in the system that is ferromagnetic, you go from ferromagnetic phase to paramagnetic phase. So basically from ordered phase to disordered phase. In this case, the system is constantly bouncing between order and disorder phase. And as a consequence of this, it has this avalanching behavior that avalanches can be of very large sizes. They can span through the whole system. And actually, that's what we see here. We have avalanche distributions of emotion and negative posts. And this avalanching distribution, there is no characteristic size of avalanches, but they actually follow power law behavior. And this is what we see in self-organized criticality systems. And actually social systems, after this, I was looking at other systems, knowledge, collecting knowledge building and other systems, and we actually saw the same behavior. So social systems are constantly in this self-organized criticality state. What this means is that while we will always have some avalanches, emotional avalanches, so one negative or positive emotion, depending on the system, can create an avalanche of negative emotions through the whole, through the whole system. What we can say in this case is that we know that there are going to be avalanches, but we don't know, we cannot never predict the size of these avalanches. So, due to the fact that we have a power law behavior, some of these avalanches can be as strong and they can actually destroy the community. So social systems are quite similar. For instance, we see this also behavior in the case of earthquakes. So kind of earthquake behavior in social systems. For the past 5 years or so, but we actually have a project since the beginning of 2023. We are very much involved in a project called C-Trust. So we actually study the rise and fall of collective trust dynamics in online communities. And this is actually funded by Science Fund of the Republic of Serbia through Prisma program. And there are 3 institutions from Serbia working on this. One is Institute of Physics Belgrade, Faculty of Philosophy Novi Sad, that is University of Novi Sad, and Institute of Nuclear Sciences Vinča. So far, we actually produced 2 things, one thing, to be precise, but very soon we will other things. So we produced a multi-platform aggregated data set for online communities. And this is a data set from, I will tell you more in a next slide, but this is the data set we actually envision that will be useful for colleagues in computational social science, so they can actually study different kind of phenomena across different kind of social platforms. We, of course, do empirical analysis, and very soon we will, actually there are already some of the data from our previous research on GitHub. And what I will tell you in the end of this session is this year we are doing a lot of agent-based modeling, and it's quite cool and uses AI as something very, very useful. So what we are doing in our project is we have empirical data from real world. We map these data to complex networks, study their structure, study their evolution. We also use agent-based modeling. When we were writing the project, LLMs were not as popular as they are today, so we kind of wanted to go with more simpler models. But now when we have LLMs, actually, we can do more realistic agent-based simulations. Both of them, we can extract important parameters, we can extract hypotheses, and next year we will test this in the experiment. And from this, our plan is to at least get some principles that tells us how collective trust emerges in different online social communities. So Medoc data set that was prepared, we collected the data from Reddit, Blue Sky, Koo, and What. Reddit, I think everybody knows. Blue Sky and Koo are kind of younger brothers or younger sisters of X. So these are the communities that kind of emerged after the Twitter was bought by Elon Musk, and they're kind of Blue Sky is quite popular through whole community, but Koo is actually a community that is more popular in Asia. And What is actually a platform that was closed, but there are very detailed data about their activity. What actually emerged after different kind of bans in Reddit. So there were several bans at Reddit of these toxic communities. And they actually kind of migrated from Reddit to a new platform called What. And What was actually closed 2 or 3 years ago, something like that, because it was relatively toxic. But what is an interesting thing, while the toxic communities like fat people hate or different kind of stuff were the reason why What emerged, interesting thing is that actually there you can also see these normal or benign communities in some sense. So people also comment pictures, they comment funny videos, they comment politics, technology, and so on. So basically, they migrated from Reddit and created an environment very similar to Reddit in some sense. And this is what we are currently studying and want to understand whether there are different kind of emergence of this collective trust in these two communities. So what we have done, we used AI in this case because so we got the raw data, but we wanted to align it, and we want to align it in the sense of topics. So we wanted to choose specific topics from Reddit and what, and then actually produce also a selection of posts and comments on Blue Sky and Coup, and we also use it for sentiment analysis. What you can use it for is collective trust. You can study collective trust as us, but you can also use it for community dynamics, migration of users between platforms, or toxic behavior, because what is also present there. You can find the paper about the data set, and it's actually accepted in one of the prestigious conferences, and Alexander Tomasevic will present it by the end of this month. And you can also still download the data if you want. It's open source. So what we have done is that for Reddit and what, we actually had very clear topics. So there are subreddits in Reddit. In what, these are subwhats or groups. We selected 6 benign groups like funny, gaming, GIFs, pics, videos, technology. But we also selected 6 groups that were originally created at Reddit, then they were banned, but we still have the data for this, and they migrated to what? And these communities are Fat People Hate, Great Awakening, $1 Million Extreme, Cringe Anarchy, Cockatoon in Action, and Men's Right. On Coup and Blue Sky, we don't have these kind of communities, and we wanted to align, at least in topical sense, these communities. So what we have done, we combined communities from Reddit and what for each of these 12 groups. We, of course, removed the stop words. We removed the common words, the ones that are occurring in more than 99% of the documents. And we also removed the documents that are shorter than 20 words and have more than 2,000 words. And we used latent Dirichlet allocation to determine the topics within each of these groups. And for each of the topic, we actually got 20 keywords. Based on this, we got a unique set of words per group, and we filtered them to retain only the least frequent English words. Actually, 1/3 of them was retained. And then we used these keywords to select posts and threads, to be honest. So posts and comments, related comments. So this is one thread on Coup and Blue Sky, and we used so-called basic filters. So we use it's enough if there is one keyword in the thread, and strict filter, we used combination of 2 keywords to select the threads in these systems. And actually, we merged all of these, and now you can look at our data set and use it to study different kind of phenomena in social systems. We also used AI to extract sentiment from the text, because we also have text we also have text. Actually, text was shared in the data set. So if you don't like Vader or text blob, you can use some other sentiment classifier. We use Vader. Vader is actually rule-based, a lexicon and rule-based classifier. So it's not trained in the sense of classical training, so it's unsupervised, but it was tuned in some sense to extract the sentiments expressed in social media, and it's quite very often used sentiment classifier. The reason is that it gives you a compound score, which is between -1 and 1, and tells you the polarity about the sentiment of the text you are looking at. To compare this, we also use TextBlob. So this is a Python library, and TextBlob is included in this. And we also used for each post and comment, we provided the polarity of post and comment, but we also provided the objectivity, so how objective is from between 0 and 10, which means subjective. We actually tested other sentiment classifiers. Roberta was also tested, but Roberta can tell you only whether the comment or post is positive or negative. So it only gives the label, doesn't give this kind of score. And we kind of opted out for this, allowing people to determine the thresholds for themselves and use it as it is. And besides this, we also use Toxigen Roberta to detect implicit hate speech in this data. And for each post and comment, we give the toxicity score, which is between 0 and 1, which tells you 0 is non-toxic and 10 is highly toxic. And if you look at the data set, this is just one of the statistical things from the data. You can see that actually, as we expected, most of the posts and comments are actually non-toxic. While we would expect this for Reddit, Blue Sky, and Poo, we wouldn't expect this for VOD. But obviously, most of the posts are still non-toxic. But on the other hand, you have this peak for very toxic posts, and it shows us that while yes, they have what has also many non-toxic posts, it actually has a comparable size of toxic posts on it. And it's the most toxic community, and the least toxic community is Q. So cool. Based on this, you can actually analyze different kind of behavior, and this is what we will do in the following months. And now I want to tell you about something that is quite interesting happening in our project. We saw the emergence of large language models in the past 2-3 years, something like that, more, maybe even a little bit more. So we use them today frequently, I would say, but believe it or not, computational social science also use it a lot, and it can benefit from LLMs, but I think also LLMs can benefit from computational social science. And while LLMs can be used in a very similar way for sentiment analysis, for toxicity, for this named entity recognition, and so on, they can also be used for other things like extraction the data from unstructured extraction the information from unstructured data, as I said, for topic modeling again. But actually, computational social science can help in LLMs. They can point out to ethical considerations. They can point out toward biases and other things that can occur in LLMs. For what we are using them is quite an interesting thing. So we use them for agent-based modeling. As a young PhD student, I developed agent-based agents for modeling emotional collective behavior in online communities. And each agent was described with arousal and valence. And this is how arousal and valence change with time. My agents were put on a network. So the blue ones are posts, the red ones are users, and this network evolves through time. As you can see, it's quite complex, but actually what I can study is one thing, so just the emergence of emotions or the self-organized criticality, depending on different kind of parameters that I get from the system. What is pro for these kind of models? They're very simple in some sense, and they allow me to understand the rough picture. But what is not that good is that they're very far from realistic situations, and I cannot actually, what goes in, that goes out, and I cannot understand, for instance, I cannot study several things like toxicity and emotions and this kind of stuff. So combining different kind of situations is not enabled in this case. And again, including topic and this kind of stuff is just not possible. So for these reasons, LLMs showed up, and I would say that it's a kind of revolution in agent-based modeling. Here we use LLMs as agents, so you can have several agent types. You can determine different kind of properties for your agents. They can be their political views, their age, their sex, their how much toxic they are. You can do different kind of stuff depending on the platform you are developing or using. You can recreate specific settings such as X, such as Reddit or other social platforms. We are now thinking how to include other parameters that are typical for humans, but actually we are not sure that LLMs are having these kind of behaviors. And what we can use them is we can use them for simulation of real systems, scenario testing, synthetic data creation, and so on. And there are now more and more platforms occurring for looking at these enabling using LLMs for agent-based modeling. Why social is something that we are used, but there are other platforms that can be used depending on situation and a system you want to model. And in C-Trust, as I said, we use Why Social. Our colleague Alexander changed the original network or the original platform so much to enable Reddit dynamics because it was originally created for X. And we use Dolphin 3 LLM for this because we want to create a situation where we will have some toxicity, and most of the LLMs are actually censored and they cannot be used for this, but Dolphin is not. So we are currently using Dolphin, and we can actually create a lot of information about each agent, enabling them like kind of heterogeneity that exists in the real system. Currently, we are testing this for technology topic, but there are other possibilities, and we are planning to do this in the future. This is just an example of the system that was created using this social media agent-based modeling with LLMs. So this is a very typical distribution that we see in social systems. So many people have few connections. They're connected with few people, but there are people that have more than almost 100 in this case, because this is a relatively small system, but you can have a power law behavior in this case. And this is an example of network that was connected using this system. Now we are going to, in the future, compare how we can actually see how well our agent-based models recreate the systems we are studying. And we are going to study the emergence of collective trust in different kind of settings. I want to thank, before I finish the talk, to my great team from Belgrade, from C-Trust team. So I mentioned Alexander several times. Alexander is assistant professor at the Faculty of Philosophy in University of Novi Sad. There is Ana Vranic, who is actually currently in Portugal on postdoc, but she's still affiliated with the Institute of Physics Belgrade. Daria Cvetkovic, she's my PhD student at the Institute of Physics Belgrade. Boris, who is both physicist and electrical engineer and mathematician, also working with us at the Institute of Physics Belgrade. There is Slobodan Maletic and Miroslav Anđelković. They're studying topological properties. They're from Institute of Nuclear Sciences Vinča. Sara Major is a PhD student at the Faculty of Philosophy Novi Sad. And Alexandra is our associated member. She actually started this and then she decided to go to industry, and she's working currently for Microsoft as their AI lead. Want to conclude, the topic or the title of this talk was AI meets social sciences, but to be honest, AI is very much part of computational and social science from the beginning. I showed you how we can use different kind of approaches to extract different kind of information from the data. but we can also use AI for prediction of evolution of the system. For instance, link prediction, node prediction, prediction of properties of the system or of the nodes in the system. I showed you how we can use them for very realistic simulations and how they can actually be used for creating synthetic data. What is clear from all of this is that explainability is something that we are still struggling with, but it's something that is must have, because what is the advantage of our approach is that when we study a social system, we can actually understand how different components or different kind of parameters of this system influence emergence of different kind of collective behavior. With AI, especially, especially with deep learning AI, we still don't have this kind of information. And as I said, computational social science needs to be part of AI. Thank you. Sorry.
Thank you, Maria. Maybe you have a glass of water before we go through the questions. If our participants have any, you can use Q&A or chat to ask your questions, or just unmute yourself and ask it. Do we have any? Maybe while we are waiting, I'm going to direct you a question in my mind, from maybe a different point but relevant point of view. AI systems can learn from online data, and if the data includes bias or harmful content, the AI can unintentionally maybe spread it. Also, algorithms may show people only content they agree with.
Yeah.
And this can lead to a polarization in the society. So how can we design AI systems to avoid spreading bias or increasing division in society? Do you have any opinions on this one?
Well, actually, I would say that computational social science, while it helped in some sense to create this bias, because actually recommendation systems came from this field, it can also help us with how to design a system, what are the ways how to kind of destroy this polarization and these kind of biases. And actually, I think through this both empirical analysis and agent-based modeling, we can actually find out what are the mechanisms, and we can actually test different kind of scenarios to understand better how these things emerge.
Because you just talked about the ethical issues arise. So something has to be done about this one.
I
For sure.
So I mentioned Anna. Anna is actually at the group of Joanna Shah. She's studying misinformation and biases in online communities. And there is a lot of people working in computational social science that try to understand how misinformation spreads and what are which kind of social structures actually help this spreading in this sense.
So, and do we have anything? No. So I have just one more coming to the high performance computing. What is the role of HPC when using large language models to analyze social media data? And how does it help in this kind of research?
Well, usually these data are huge. So if you want to analyze them in, in a relatively short time or prepare these data sets, high performance computing enables you to parallelize this process and do it in parallel. Regarding LLMs, it takes a lot of time to run one simulation in our case. And actually, we are planning to apply for JU this AI access to be able to do this, because we are currently having relatively limited resources here, and we really need a bigger resources for this.
Now you just use your workstations, and
for now we are working. No, we have a paradox cluster here at the Institute of Physics Belgrade. So we actually have some computational resources for CPUs. For CPUs,
Mm-hmm.
we're really good. So for this analysis of
GPUs.
extraction of emotions and this kind of stuff, we are okay. But for actually running these LLMs, agent-based simulations, for that we need GPUs. And yeah, actually, the cluster, the platform currently, as it was made, enables you to do this in parallel. So you can use
Mm-hmm.
more than one GPU for running
Mm-hmm.
these language models, which actually allows you to use larger models, which are better in social reasoning. So
Mm-hmm. And maybe after you applied and work on these supercomputers,
we
AI-based
will present
supercomputers,
more.
yes, yes, another joint activity.
Yes.
Yeah, and that's a promise.
Yeah.
Okay. I think we don't have any questions from the participants. I think it's quite useful for all of us and all the participants. And we would like to thank you again, Maria, for your contribution and insightful presentation today. And our next seminar will take place in 2 weeks later on Tuesday, June 24th, titled AI Meets Healthcare. And please don't forget to register if you're interested. And we look forward to seeing you in the next session. Thank you all for joining and have a great day. Thank you,
Thank you.
Maria.
Thank you
Bye.
very much. Thank you.
Bye bye.
Bye.
Bye.